So on this homework, I'm going to ask you to find the vertex, the axis of symmetry, the Y-intercept, and then obviously graph it, and then state the domain and range. Actually, we're going to hold off on the domain and range. We'll do that a different day. The domain and range we'll talk about on another day. So number one, step one would be to find the vertex. The vertex is a coordinate, an x value, and a y value. You find that vertex by using the formula x equals negative b over 2a. And of course, you want to use parentheses to use this formula correctly. So a negative parenthesis over 2 times parenthesis. So if you look at your equation, the a value is 1, the b value is with x, negative 2, the c value is all by itself, the negative 1. But we don't even use c on this. So let's plug in the b value, which is negative 2, the a value, which is 1. So when we simplify this, we're going to have x equals positive 2 over 2. 2 over 2 is really just 1. So we just found the x value of the vertex, which is 1. To find the y value, you simply plug in the value of 1 into your x positions. So let me rewrite it over here on the side and plug in 1. As you can see, we're plugging it in with parentheses. So we're going to plug in the 1 inside the parentheses, and let's do the math correctly according to the order of operations. You're going to begin with the exponents. 1 squared is 1. Then you're going to bring down the rest, times 2 times 1 minus 1. That's really 1 minus 2, because 2 times 1 is 2, minus 1. If you go 1 minus 2, you get negative 1, and negative 1 minus 1, that's negative 2. So for your input of 1, your output is negative 2. So your vertex has the coordinate 1, comma, negative 2. So let's go to that coordinate, 1 on the x, negative 2 on the y. Let's put a dot right there. Let me do it in red better. Now, what's the next thing to do after you plot your vertex? It's to graph your axis of symmetry. So you're just going to draw a dotted line, a vertical line going right through that vertex. That's the axis of symmetry. Now, we still need more coordinates. So normally I would say make an XY table and plug in 2 easy numbers that are on one side of the axis of symmetry. But since we know that the a value is 1, we could use that pattern 1, 1, 2, 4, 3, 9. Now that only works with the a value of 1. So we know that the a value is 1, which means that it's opening up. So we're going to use the pattern 1, 1, 2, 4, 3, 9 from the vertex. So I'm going to go over 1 over and 1 up and put a dot right there. And then we're going 2 over, 1, 2, and then 4 up. 1, 2, 3, 4, and put a dot right there. And if we go 3, 9 from the vertex, so you always go back to the vertex and continue with your pattern. 3, 9, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. I'll be 2 units off, but that's okay. I'll draw it just so you guys could see. And we need to map these coordinates over to the other side. So it's simply measuring or counting 1 unit away, 1 unit away. And also this one up here, 2 units away. So 2 units away would be right there. So mapping them over, you'd get these blue coordinates. But it's not even necessary to go all the way off the graph. So let's just draw our parabola right through those coordinates. What was the y-intercept? If I asked you for the y-intercept, that's where the parabola crosses the y-axis. The y-intercept is the coordinate 0, negative 1, if you wanted to state the y-intercept. But that's how to graph. It's pretty easy, especially if your a value is 1. Number 2, this one also has an a value of negative 1. Remember, the a value tells you how wide your parabola is or how narrow it is. And all the parabolas with the a value of 1 have the pattern 1, 1, 2, 4, 3, 9 from the vertex. So number 2, let's start with the vertex, which is a coordinate. And again, we're going to use the formula x equals negative b over 2 times a. And again, we're going to use parentheses instead of the letters. Then we identify the a value is negative 1, the b value is 0, and the c value is 3. So since the b value is 0, you plug in a 0 up here, and the a value is negative 1, plug in a negative 1 down there. You're going to end up with x equals negative 0, which is still 0, over negative 2. That's saying x equals 0. So x equals 0 on the vertex. To find the y, you simply plug it in. 0 squared is 0, plus 3 is 3. So when you plug in 0, you get an output of 3. After that, you're supposed to go to an XY table, but since the A value is 1, once again, we could use the pattern 1, 1, 2, 4, 3, 9 from the vertex. So let's first graph that most important point of the parabola of the vertex, which is at 0, 3. 0, 3 is right here, that red dot. Now let's draw an axis of symmetry, a vertical line running right through it that's going to provide us a reflection, which will help us graph this parabola a lot faster. Now from this vertex, let's use a pattern 1, 1, 2, 4, 3, 9. So 1 over, and it doesn't matter if you're going to the left or to the right, as long as you go 1 over, 1 down, and put a dot there. And then you go back to the vertex, 2 over, 1, 2, 3, 4 down, put a dot there. And last but not least, back to the vertex, 3, 9, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 1 unit off. Now you don't have to graph it if it's off the graph. I'm just showing you that it could be done. And we're going to map it over to the other side. So put a dot right here, put a dot over here, and put a dot over here off the graph. Let's connect our dots and just put arrows pointing at those that are off the graph. And that is our parabola. The Y-intercept happens to be the vertex in this case. Remember, Y-intercept is where it crosses the Y-axis. If I asked you for the X-intercepts, that would be a little harder because it's like 1 point something. It's not really 1.5, it's like 1.6 or 1.7 for this X-intercept, and maybe negative 1.6 or negative 1.7 for that X-intercept. We will have to talk about X and Y-intercepts later. Now number 3 is different because you cannot use the pattern. So let's work through this one using all the steps. Step 1, find the vertex. The vertex is a coordinate. How do we find that coordinate? With the formula x equals negative b over 2 times a. We're going to use parentheses to find out that x value. We're going to label a is 2, b is negative 8, c is 5. So the b value is negative 8. You plug that right inside the parenthesis. The a value is 2. So your x will be positive 8 over 4, which is really 8 divided by 4 is 2. So we found that the vertex x value is 2. We still need the y value. And how do we do that? We simply plug it in. So I'm going to plug it in over here on the side. I'm going to plug in 2 for x. There's my equation. Let me plug in the value of 2 that I just found with the formula. And now let's do this math with PEMDAS. So 2 squared is 4. You're going to have 2 times 4, and then 8 times 2 is 16. Bring down the minus, and then plus 5. We still have that multiplication to do. 2 times 4 is 8. 8 minus 16 plus 5. 8 minus 16 is negative 8. Negative 8 plus 5 equals negative 3. So we just found out with this work that the y value was negative 3, the y value of the vertex. So now we know the x value was 2, and the y value is negative 3. So let's graph that coordinate, the most important coordinate of the parabola, the vertex 2, negative 3. So let's go 2 on the x, negative 3 on the y. Again, 2 on the x, negative 1, 2, 3 on the y. There it is. There's my vertex. The next thing to do is to draw your axis of symmetry, the vertical line that goes right through that vertex. And then after that, you obviously need more coordinates. So you're going to do an x, y table, and you're going to plug in 2 points that are on the same side of the axis of symmetry. So would it be a good idea to plug in 0? 0 is always the easiest number, and in this case, that's fine. Plug in 0. So if I were to plug in 0, 0 squared is 0, 2 times 0 is 0, 8 times 0 is 0, 0 take away 0 is 0, plus 5 will be 5. Ladies and gentlemen, whenever you plug in 0 into a standard form quadratic trinomial, your c value is always going to be the answer. Let me repeat that. When you plug in 0, everything's going to cancel out except your c value. So the c value of 5 is your output. If I were to graph the coordinate 0, 5, 0, 5 is up here right on the edge of the graph, right? 0 on the x, 5 on the y, it's right there. Now, if you want to find one more point that's between here so it doesn't look like a straight line, then we would like to plug in the value of 1, right? If you plugged in something over here like negative 1, it would be off the graph. So let's plug in 1, which should be between that point and this point. So let's plug in a 1. And if we do plug in a 1, let's do this in our head. 1 squared is 1. 2 times 1 is 2. Let me actually write that down, 2 right here. And then plug in a 1 right here. 8 times 1 is 8, so you have a minus 8. So you have 2 minus 8 and then plus 5. 2 minus 8 is negative 6, and negative 6 plus 5 is negative 1. So when I plug in a 1, I get out a negative 1. So let's go 1, negative 1, and put a dot right there. So that's already enough for my parabola. All I have to do is map these coordinates over to the other side. So I'm going to take this one and go 2 units from the axis of symmetry this way and put a dot right here. So I'm mapping it over. This one as well, it's 1 unit away, so go 1 unit away and put a dot right there. All you have to do now is connect your dots, and you have your parabola. Whoa, that was off. Let me erase that. And there's your parabola. I hope that makes sense. It's really not that bad. Now this one might confuse some people because it has the a value of 1/2. Let's work this out, guys. Step 1, let's find the vertex. The vertex is a coordinate x and y value. We find the x value by using the formula x equals negative b over 2 times a. We're going to use parentheses to be able to work this out correctly. We're going to identify the a value, which is 1/2, the b value, which is 1, and the c value, which is negative 3. We don't even use the negative 3. Let's plug in the b value of 1 and the a value of 1/2. Some people get freaked out with this fraction, but it's really no big deal because the numerator, x equals, well, negative 1, that's clearly up on top. 2 times half, what's half of 2? It's just 1. So what we really end up with is x equals negative 1. That is the x value of our vertex. Now all we have to do is find the y value. Now I do admit this is a little challenging because we do have fractions involved. Let me rewrite my equation but with parentheses instead of the x's. And I am plugging in a negative 1 for the x because that's what we found for x. X is negative 1. So put a negative 1 right here and right there. And then we do the math according to PEMDAS. Negative 1 squared is positive 1. So what I really have is 1/2 times 1, positive 1, plus a negative 1 minus 3. So 1/2 times 1, that's just 1/2, and then minus 1 minus 3. So 1/2 plus negative 1, or 1/2 minus 1, if you have 50 cents and you owe $1, you're still going to owe 50 cents. So 1/2 minus 1, that's really a negative half. And then minus 3, if you owe 50 cents and you owe $3, you're going to owe $3.50. I hope that makes sense. So our vertex is, the x value is negative 1, the y value is negative 3.5. So the y value of the vertex is negative 3.5 or negative 3.5. Let's see what that looks like when we graph it. So you're going to go negative 1 on the x and 3.5, halfway up. So it'd be right there in the middle. So again, negative 1 on the x and 3.5, or I'm sorry, negative 3.5. Man, I almost messed up. So negative 1, negative 1, 2, 3.5. So you'd be halfway down this way. So let's actually graph that right there. So this is going to be my vertex, which is perfectly in between the level negative 3 and negative 4, negative 3.5 on the y. So we're going to draw our axis of symmetry like always right through that vertex. And now we just need more coordinates to graph. So let's go to an XY table like always. Let's plug in an easy number. What's the easiest number to plug in? 0. Plug in 0 and we will have 0 squared. Remember, everything cancels out except for the c value. So when you plug in 0, you get out a negative 3, and that is a coordinate. Let me graph it in red. 0, negative 3 would be right here. And then we could plug in another number. What would be another number to plug in? Another nice number to plug in? A 1. Okay, now let me tell you this, guys. If we do plug in a 1, it'll work out just fine, but we're going to have fractions because 1 squared is 1, and 1/2 times 1, we end up with a half, which is totally fine. But what if we try to plug in 2? If we plugged in 2, right in here, that'd be 2 squared. What's 2 squared? What's 2 squared? 4. And what's 1/2 times 4? 2, right? So you really would get a 2 for the first part, and then if you plugged in a 2 for the second one, it would be 2 plus 2 minus 3. So if you plugged in a 2 correctly, you would get an output of 1. So that worked out really nicely. So let's plug in 2, and let's plug in 2, 1, the coordinate. Let's graph it. So 2 on the x, 1 on the y, there it is. Now if I map it over to the other side of this axis of symmetry, I'll have a really good looking parabola. So this one is 1 unit away, so go 1 unit away this way, and you have that coordinate. This guy is 1, 2, 3 units away, so 1, 2, 3 units away, and you have your dot right here. Now as you can see, if you connect the dots, we're pretty good. Now this parabola is slightly wider than the usual parabola. Remember the parent graph where the a value was 1? Then that was a regular U-shaped curve. This one's a little wider because the a value is closer to 0. The closer you get to the a value of 0, the closer or the wider this parabola will get. So this one is identical to this other one that we just did, so there's no point in doing it again. That was a typo on my fault. I shouldn't have repeated that. So let's move on to this guy right here. Again, let's find the vertex, which is a coordinate, and you find that coordinate using x equals negative b over 2a. And using it correctly would mean that you use parentheses to plug in your values. Identify your a value, which is 1. Your b value is not there. Your c value is negative 3. So your b value happens to be 0 because it's not there. Your a value is 1, but either way, negative 0 divided by 2, x is 0. So your vertex x value is 0. To find your y value, simply plug it in. So plug in 0 right there. 0 squared is 0. Minus 3 is negative 3. So your vertex x value is 0, negative 3. Put a dot right there. So graphing the vertex. The very next thing to do after you graph the vertex is to draw your axis of symmetry, the vertical line that crosses right through it. And then, of course, you need more coordinates, so you go to an XY table. But since you recognize that your a value is 1, you could use the pattern 1, 1, 2, 4, 3, 9. So all you have to do is think about whether it's opening up or down, and we know the a value is positive, so it is opening up. So from the vertex, and you always go back to the vertex, okay? So from the vertex, you go 1 over, 1 up, and you put a dot right there. And then you go back to the vertex, and you go 2 over, 1, 2, 3, 4 up, and put a dot right there. And last but not least, you go back to the vertex and go 3 over, 1, 2, 3, and 9 up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 1 off. You didn't have to draw that last one because it's off the graph, but I like drawing it anyway. And let's map them over to the other side of the axis of symmetry. So it's 1 unit away, go 1 unit this way. 2 units away, go 2 units this way, and put a dot there. And of course, if you were out here on this one, it's 1, 2, 3 units. So 1, 2, 3 units would be out here. Again, you don't have to graph these dots that are off of the graph. Anyhow, let's connect the dots and we'll have our parabola. So I like to draw those dots up there so I could actually point my arrows at them. But that's the perfect parabola right there with the a value of 1. Has a pattern 1, 1, 2, 4, 3, 9. It's that easy, guys. Let's move on to this one right here. Let's find the vertex. And how do we find the vertex? You use the formula x equals negative b over 2a. And of course, to use that appropriately, you're going to use parentheses. X equals negative parentheses over 2 times parentheses. And we're going to be plugging in our a value of negative 3, the b value of negative 6, and the c value of 2, even though the c value doesn't get used on this formula. So the b value is negative 6, the a value is negative 3. So we end up with x equaling positive 6, because a negative divided by, or a negative times a negative is a positive, over negative 6, because 2 times negative 3 is negative 6, which means that x equals negative 1, and that is our x value of our vertex. If we want to find the y value, you simply plug in that x value into the original equation. And I'm going to do it right here on the side. I'm going to rewrite the equation without x's with parentheses. And of course, in there, we're going to be plugging in our x value of the vertex, which is -1. We found that with the formula. Then after that, we use order of operations, exponents. First, -1 times -1 is +1. Let me bring down everything. I have a multiplication of 3. Let me rewrite everything. -6 times -1 plus 2. And then I'm going to do the multiplication. -3 times 1 is -3. -6 times -1 is +6. Bring down the plus 2 at the very end. And we go from left to right. -3 plus 6, that is 3. And 3 plus 2, that is 5. So when the x value of the vertex is -1, the y value of the vertex will be 5. So let's graph that. -1 on the x, 5 on the y. It's way up here right on the edge. We're going to draw an axis of symmetry going right through that vertex, that vertical line that goes right through the vertex. And then we're going to use an XY table to find more coordinates. Now we want to pick two values that are on the same side of the axis of symmetry. The absolute easiest number to plug in is 0. Anytime you plug in a 0 into a quadratic trinomial equation, your answer, your output will be the C value, right? If you go 0 squared, 6 times 0, you're going to have 0 plus 2, that's going to be 2. So for the input 0, I get an output of 2. Let me graph this in red. 0, 2 is right here. And let me plug in one more value that's on the same side. So here's my axis of symmetry. We have this coordinate on the right side, so I want to plug in another value that's on this side. So if I plugged in 0, that was great. I want to plug in 1 now. So let's plug in a 1. Now let's see what we get. And of course, you might want to show your work. I'm going to rewrite this whole thing right above it with parentheses instead of the x's. There it is. And now I'm going to be plugging in the value of 1. And I want to do PEMDAS. 1 squared is 1. -3 times 1, that is -3. 6 times 1, that's -6, and then plus 2. So when we do this math, -3 minus 6 is -9. -9 plus 2 is -7. So if I graph the coordinate 1, -7, that's going to be way off the graph. I'm talking, well, not way off, but 2 units off the graph down here. Okay, so once again, if you from the origin 1 and then -5, 6, 7, you'll be down here. You can map it over to the other side and you'll be over here. I want to do that one in blue. Now, of course, it's not necessary to do these dots that are off the graph, but you do definitely want to map this one over. Connect the dots. And like I said, I just draw those dots that are further off just to get an idea of where my parabola is actually going. Okay? But you could just leave this part of the parabola and you're done. That's a good graph. If I asked you for the Y-intercept, that would be the location 0, 2. If I asked you for the x-intercepts, that would be something like -1, -2, -2.2 or something like that. It'd be a decimal between -2 and -3. Over here it'd be a fraction or a decimal between 0 and 1. Just to let you know, x and y-intercepts will start popping out later. Last one. Okay, let's do the vertex. Let's identify the a value of -1/3, the b value of 2, the c value of 3. Let's plug in the b value of 2, plug in the a value of -1/3. And at this point I realize that we're going to end up with fractions. And you know what? This is just too long of a video. I don't want to do anything with fractions. How about this? Let's just scratch this one out. Let's not worry about this one. Yay! Okay, we're done.